is Chris Freeman. I'm a technical fellow for augmented reality, although I don't actually do much technical anymore, unfortunately. And I'm the lead, so I look after a huge digital manufacturing team within the AMRC. So it's worth pointing out, we are the AMRC, we're Boeing. I'll do a little bit of background because we're a little bit unique in terms of how we sit and how we operate. So Boeing are one of our tier 1 partners, but we work with a whole number of aerospace, automotive, construction manufacturers. We're a university at heart, so we are academic. We look at a range of different technologies, a range of different applications, covering composites, covering automation. But the real big themes at the minute is digital transformation, and how do we utilize the onset of new technologies, new methodologies that are coming through onto the market, and how do we apply them to manufacturing challenges. So as you can see, we've got a huge range of capabilities here, but the key thing here is where we sit. So you might not be aware of the TRL levels developed by NASA in the 70s. So this was a way of benchmarking technical competency and capability within an approach to adoption for predominantly manufacturing-based technology. So we operate in about 3 to 7. So the idea is we take ideas, we take concepts that come out of academia, and then we develop them, we prove it at a scale, we prove at rate. So that the type of partners that we're working with, when we've finished a project, ideally we have this recipe, we have this set of ingredients that we hand over to the industrial partner, and that they can then take forward, knowing full well that the application has been tested, and we've got some good data there that backs up the value and the return on investment behind it. We work with a whole range of different partners. And we have 2 different tiers of partners, but we're the only organisation in the world that has Airbus and Boeing on our same board of directors, but we have BAE Systems in there. We have people like McLaren Automotive, we have JLR members as well. So there's a huge wide range of industrial OEMs and within the supply chain, and that's critical as well. So we want to do in supply chain engagement in terms of how do we not just improve the big boys here, how do we actually bring the supply chain with them as well. I personally work within Factory 2050, so this is where the robotics and automation competency houses. And we've been doing robotics and automation for a number of years. But as we've seen more kind of human in the loop driven requirements around manufacturing capability. So automation is great. Automation does a lot of good things, but automation has a sweet spot. And we need to be considering that if automation isn't suitable, then we need to be able to actually deliver the things that automation gives us, which is right first time, just in time, but how do we enable a human to do that? So we start to look at things like MES systems, we start to look at digital work instructions, we start to understand the use of technology to better control our manufacturing systems. And a lot of the work we do is actually based around system integration, getting X talking to Y. So I'm very fortunate that I have a very talented team that work below me. It's quite unique in terms of how the space is developing over the past 5 years. Really, that my team comprises of game developers, it comprises of data scientists, it comprises of web developers, as well as these more standard software engineers. So within 2050, we've gone from being a very mechanically orientated team to a real diverse set of people. And it's been a huge challenge in terms of skills, and we're not going to touch on skills too much here, but in terms of how do we attract people into engineering, how do we attract people into manufacturing, how do we get the skills to deliver some of these digital transformation? It's a real big problem. And it's also worth showing here in terms of the types of companies we're now working with. So we're not just working with your core manufacturing providers, we're actually engaging with some of the large system providers. We're doing a lot of work with the likes of Deloitte, with the likes of Accenture, because they want to look at digital transformation themselves. They want to understand how do they deliver the kind of change that they've delivered maybe in the banking sector or other sectors. How do they apply that to manufacturing? So visualization driven manufacturing. So we have a problem. Industry 4 is brilliant. Everyone keeps telling us it's brilliant. A lot of people say we've been doing Industry 4 for quite a while. We've just now got a term to define it better. But the crucial bit is this cyber physical systems, and it's all about interconnectivity. It's all about how we have smarter systems, smarter products, which is actually creating so much more complexity. And it's not just a complexity within the manufacturing process, it's a complexity within the asset that they then have to manage downstream. And there's a real big subject matter coming through, which is called TES, which is through life engineering services, where we're not just considering the manufacturing, we're considering the whole value ecosystem around that product. So it's really cradle to grave, and how do we start to better manage, maintain, control our asset post-manufacturing? We put so much emphasis onto manufacturing, but actually often we forget a lot of times what we have to do to maintain and manage manage the asset throughout its life. So we're obviously we're seeing huge change in terms of great levels of data, huge more levels of connectivity in terms of how systems are communicating together, and then the intelligence that comes off of the analytics. So that whole paradigm of data, information, knowledge. This is the big challenge that we have, and this is where AR can really start to help us, because it starts to break down those barriers. And the big thing that we start seeing is context. So people have tried to map this before in terms of what is the best visualization method for the particular challenge, and we have rather convoluted solutions like this which are outdated. We then move on to more traditional things that we see on manufacturing shop floor. We have huge, great spreadsheets. We have rather unintuitive systems that we have to interface with. And we're starting to evolve that. We're starting to change. The narrative's moving. We're seeing more touchscreen systems. We're seeing more dashboard-driven systems come through. And these are, with the likes of Power BI, some of the people working with, they're providing these kind of dashboard systems. And that's great. But the next step is context, because what this doesn't give you is context. What AR gives you is context of that solution. So we can start to see, and we've all seen these type of vision pieces. These are great, and these very, very much represent the future. But the critical element is, well, where are we now? What's realistic? What's suitable now? So at the AMRC, we're quite fortunate that we've been tasked with challenging a lot of this, trying to understand a little bit more about how do we address that problem, and how do we address it on those different TRL levels. So when people come to work with us, they will give us a target TRL. So it might be that we want to start looking at an application which is ready for deployment. So it might be they want us to look at something more visionary. So the crux of a lot of work we do here is looking at how do we take information data that already exists. So this is an application we developed for Spirit Aerosystems, and this is a ThingWorx IoT interface with their MES system. So the current challenge they have with their MES system is that it is relatively inflexible. It does everything they want, but actually they don't have a huge amount of control of how to maintain and manage that process. So what we've actually started to do is to bring in different technologies here to better enable that process. So you can see here we're bringing augmented reality. So we do historically we've done a huge amount of work around projected technologies, and projection is great, fantastic, robust, well known, but often it's deployed in point isolated solutions. And actually, I'm a big fan of what Paul's presented previously, because Paul's example is one of the few scenarios I've seen whereby a company is trying to address the whole narrative in terms of deployment, really understanding what does deployment mean, rather than developing a single point solution to solve one thing. It's actually a whole narrative across the business and across the IT. So you can see here, actually, we've got a closed loop system. So we've got a projection system which is being driven by the IoT, the ThingWorx dashboard. This dashboard is actually telling you where you need to drill next, or where you need to use the torque wrench next. It's a smart torque wrench, so actually it's a completely closed loop system, so the wrench knows what it needs to do. It's been programmed by the system, and actually the wrench tells the system when it's done the task, and then it automatically steps on. The novelty thing about with this application was actually the ability to deal with non-conformances. So the real big challenge for them was how they deal with those non-conformances, and actually it would cause a halt on the production line. By almost stepping above that manufacturing execution system, we can actually start to address the non-conformance, note it, but actually carry on our critical path, so actually we don't have a stoppage. And then it means that later in the process, an engineer can then come on and actually go for the quality process and address the solution or address the particular challenge. And again, this is driving the projection system. So that particular application is in the process of being looking at, well, can we migrate that to a HoloLens? But the whole value piece behind that was that it was high TRL. It's something that works and something we can deploy now. So I'm going to step back quickly. So we've done a huge amount of work historically looking at monocular-based devices, and a lot of these when we have a challenge in terms of expectation management. So when a client comes to us to speak to about technology, speaks about augmented reality, they go, well, we want to use AR on the shop floor. Well, this is great, but what do you actually want to do? What have you considered? Have you considered the pitfalls? Have you considered some of the challenges or some of the barriers? So it's understanding actually, what do you need to do? What is the minimum viable products? What do you need to do to be delivering value against that? And often text, image, videos, we don't necessarily need 3D content. We don't necessarily need complex animations or interactions. Sometimes the simplest solution is the best solution. And hence why we do a huge amount of that's kind of tablet-based work. I'm just going to step forward. But in terms of some interesting, more novel project work we've been doing. So this has been looking at electrical cabinets, so wire testing. And this is also a really interesting narrative in that a lot of people look at this and say, well, this is an AR project, this is an augmented reality HoloLens application. To us, it's not. To us, it's an IoT project, because there was a huge step change in this application in that the testing procedures that need to be conducted were all paper-based. So an engineer would come up to the cabinet, they'd actually then go through the contents of a cabinet, pull out the appropriate testing routines from the manual, and then they'd go through the multimeter testing process. They'd put that information onto a clipboard, they'd then go home in an evening and transfer it into a spreadsheet. So the task one was digitization. And again, the narrative we often discuss at the AMRC is around how you approach that digital transformation journey. And AR is a great endpoint of that digital transformation, but there is aspects that you can do before then that start to give you a huge amount of value and a huge amount of gain. And the critical piece to this was the IoT multimeter. So what that enables us to do was create a live Bluetooth connection to the headset, so that as the instructions were telling you where you needed to place the probes, you can see you've got a heads-up display there. We're giving you the continuity results, and then through voice control, that was automatically then going back into the database. So it was a completely closed loop system. We'll just step back quickly. Okay, so it's a completely closed loop system. Okay. I seem to lost control of my clicker. So the next application we're going to have a look at quick here is some work that represents a real shift in manufacturing for us. So historically, we've worked a huge amount with aerospace companies, but now we're seeing companies from construction come into speech because they want to look at how do they manufacture things in a factory, how do they look at building houses more effectively, more efficiently. And from a HoloLens perspective, construction is great because we start to look at how the tolerances that the construction companies use and apply to and adhere to are actually far more suitable to the tolerances that the HoloLens can deal with and cope with. So we've done some kind of proof of concept work around this, but as Paul demonstrated, there's a huge challenge in terms of the data flow, the data process. How do we actually get data from A to B? And there's a huge amount of legwork that needs to be done in these types of scenarios to do that. So we started to look at the challenge around capture, around asset capture and asset knowledge. And we actually developed a little application which was again across multiple devices. I mean, holistically, ultimately, you'd probably want to do this purely on a HoloLens, but again, the HoloLens doesn't map accurately enough for us to do this. But again, if we can start to bring different technologies together, we actually have engaged with a couple of smart tool providers who are now looking at developing the hardware to back this application up. So how we can go through a process of actually scanning an asset, identifying what the asset is, putting that into a database. So at the minute here, what we're actually going to do is realign that scan. So our initial scan we've done with a separate device, we're now having to align that in the HoloLens. So holistically, this should almost kind of be taken care of completely. Once we've actually mapped together, we can start to identify what assets are available and actually mark those in. And these are then obviously then going back into a database. So we actually were working with a German research company who were looking at algorithms for automatically subsectioning point cloud, but the technology wasn't quite there, it wasn't quite mature. So, and again, these are very much kind of vision pieces. So how we can start to bring in thermal cameras, how we can start to bring in different sensors, different technologies, and actually overlay that to create a much more rich environments. So again, we've had to create very much cut and shut jobs here, but by actually having access to the information, being able to geolocate that, and being able to pull that information through shows how actually we can bring huge amounts of information together. So the real clever bit was using the wall scanner and how actually we could start to identify assets that were hidden behind a wall using your standard kind of Bosch mapping tools and actually having that mapped in the HoloLens. So again, they're one of the providers that we've been discussing with, saying, well, actually, you know what? If you were to put a bit of more functionality into your devices, you could do so much more with them. You could actually have a much more rich device or rich product that was available. So again, I think there's a lot of work. It was same applied to the IoT multimeter before. There's a huge educational process. So we're seeing technology comes to the market, but they haven't necessarily had the right leadership or the right direction to create something that's perfect. So a lot of what we do is kind of the education, saying, well, if you can do this, if you can do this, if you give us an API in the first instance, it makes life so much easier. So The next bit we're going to move on to is looking at something called digital twins. So digital twins is a bit of a kind of a buzzword bingo at the minute, but we've done quite a bit of work in this space. Now, I will apologise slightly. The next two examples you're going to see are more VR-based, but I think it sets the scene in terms of where we are going from an augmented reality perspective. So a little bit of information there, but essentially we're looking at the three pillars that we need for a digital twin from our perspective. There are different opinions on this, but you need a model, you need a connectivity between the model and the physical asset, and you need something in real time. There are three modes. There are supervisory, interactive, and predictive. And the two examples we're going to see are supervisory and predictive. So the first example we've got is work that we've been doing with Rolls-Royce. So this is actually looking at a pump installation, and we're taking live feed, live data off this pump within a virtual environment. We've discussed a HoloLens application for this. It's on the roadmap for next year. But in the first instance, because their critical path was all about remote support and having remote access to this information, it was governed by to be a kind of a virtual space. So we can start to bring all the information up. We've got a live feed in terms of what the pump's doing at any point in time. We can actually start to pull up different pumps and start to look at the relationship between them. So we've got some live analytics that's kind of happening in the background here as well. So again, it gives someone the opportunity to kind of remotely access an asset or remotely access a site, and have a live view of what's happening at any point in time. And that might be from an OEM who is managing multiple sites simultaneously, or it might be an OEM who's actually having sight of their supply chain and wants to have confidence that the part they're manufacturing, the part that's maybe on their critical path, that's going to be delivered on time, that process is being controlled appropriately. So this is very much, I think, where we're moving towards. And I think there's a huge amount of return of investment work that needs to be done to better understand where the value sits in these type of applications. And I think it's very easy to say, this is great, this is shiny, this is the thing we should be doing, or actually, what do you get just from a screen? How much value is there from a screen or a normal TV screen? The next example we're going to see is where we're looking at the predictive side. So the digital twins are great. We've got a nice example here. So we've got the physical robot. It's a flexible fixture which is monitoring. Where there's loads of encoders on there, loads of sensors on there. We know what that robot and that fixture is doing at any point in time. Going through to our virtual model, the virtual model mimics it. Great. As a supervisory model, that's great, but we want to do far more with it. So what we've started to do is to overlay the simulation. So in manufacturing, we have a really bad habit of simulating to the nth degree, but then actually not referring back to that simulation when we do. So if we can start to have an easier way of actually referring back to a simulation, by overlaying that on the physical, we get a direct report as to where we are in terms of our manufacturing cycle. Are we actually going too fast? Are we behind schedule? Where are we on certain WIP components? So this is utilizing or accessing something called discrete event model simulation. So it's a numerical modeling based simulation technique, and it allows us to basically profile a particular process and profile each action. Those actions are obviously being baselined against what's happening in reality, and we can start to understand the deviation. So this is a great example as to, again, what are the next steps. And with the company that we've been working with we've been working with two companies. We've been working with Siemens, we've been working with a company called Lana, who have a product called Witness. The next step is to actually start to look at those type of applications and work out, well, when we see a red flag, when we see a process that is out of scope or out of tolerance, actually can we start to look at the live implication of that? Can we start to go through and re-simulate and re-evaluate and actually come back with a figure that says, okay, to alleviate this, we need to do X, Y, and Z. Bit of self-marketing. So we are part of the High Value Manufacturing Catapult. So we're part of a UK national research organisational structure, probably a bit similar to the Fraunhofer's in Germany. We've recently published 2 reports, one on immersive technologies in manufacturing, probably slightly more VR focused, but the feasibility of immersive digital twin, I think, is a fantastic read. It's well worth downloading, having a look, because we talk about the different modes of digital twins and we talk about the different types of applications. So that is me. That's a bit of a whistle-stop tour. Are there any questions? Thank you.
Thank you, Chris. Do we have any questions from the audience?